Now let us study hypotenuse side theorem, theorem 3.2. Two right-angled triangles are congruent if the hypotenuse and a side of one triangle are congruent to the hypotenuse and corresponding side of the other triangle. See the figure alongside. It is given that in triangle ABC and triangle PQR, hypotenuse AC is congruent to hypotenuse PR. Segment AB is congruent to segment PQ. Angle ABC is equal to angle PQR is equal to 90 degrees. We have to prove that triangle ABC is congruent to triangle PQR. Construction. Let us take point S on ray RQ such that point Q is in between R and S, and segment BC is congruent to segment QS. Let us see the steps of the proof. In triangle ABC and triangle PQS, it is given that segment AB congruent to segment PQ, angle ABC is congruent to angle PQS as each angle is of 90 degrees. According to the construction, segment BC is congruent to segment QS. Therefore, according to the side angle side test, triangle ABC is congruent to triangle PQS. Let us mark it as statement 1. By corresponding sides of congruent triangles, segment AC is congruent to segment PS. But it is given that segment AC is congruent to segment PR. Therefore, segment PS is congruent to segment PR. Let us mark it as statement 2. Therefore, according to the isosceles triangle theorem, angle R is congruent to angle S. Let us mark it as statement 3. Now in triangle PQR and triangle PQS, from statement 3 we can say that angle R is congruent to angle S. Also it is given that angle PQR is congruent to angle PQS. From statement 2 we have segment PR is congruent to segment PS. Therefore, by side angle test, triangle PQR is congruent to triangle PQS. Let us mark it as statement 4. Therefore, from statements 1 and 4, we can say that triangle ABC is congruent to triangle PQR. Coming to theorem of 30 degrees, 60 degrees, 90 degrees triangle. Theorem 3.3. If the angles of triangle are of measure 30 degrees, 60 degrees and 90 degrees, then the side opposite to the angle of 30 degrees is half the hypotenuse. See the figure alongside. It is given that in triangle ABC, angle A is equal to 30 degrees, angle B is equal to 90 degrees, angle C is equal to 60 degrees. We have to prove that BC is equal to half of AC. Construction. Let us take point D on ray CB such that BC is equal to BD. Draw segment AD. Let us see the steps of the proof. In triangle ABC and triangle ABD, angle ABC is congruent to angle ABD as each angle is of 90 degrees. According to construction, segment BC is congruent to segment BD. Segment AB is congruent to segment AB as they are the common side. Therefore, according to the side angle side test, triangle ABC is congruent to triangle ABD. Therefore, segment AC is congruent to segment AD, since they are corresponding sides of congruent triangles. Therefore, according to the isosceles triangle theorem, angle C is congruent to angle D. It is also given that angle C is equal to 60 degrees. Therefore, angle D is equal to 60 degrees. Now, in triangle ADC, we have angle D is 60 degrees and angle C is 60 degrees and angle DAC is equal to 60 degrees. Therefore, triangle ABC is an equilateral triangle. Therefore, since they are the sides of equilateral triangle, AC is equal to DC. Now, multiplying both the sides by half, we get half of AC is equal to half of DC. But, according to construction, half of DC is equal to BC. Therefore, BC is equal to half of AC. Hence, in 30 degrees, 60 degrees, 90 degrees triangle, side opposite to 30 degrees is half of the hypotenuse. Converse of 30 degrees, 60 degrees, 90 degrees theorem. In a right angle triangle, if the length of one side is half the hypotenuse, then the measure of the angle opposite to that side is 30 degrees. See the figure alongside. It is given that in triangle ABC, angle ABC is equal to 90 degrees. BC is equal to half of AC. We have to prove that angle BAC is equal to 30 degrees. Construction. Let us take point D on ray CB, such that BC is equal to BD. Let us see the steps of the proof. According to the construction, BC is equal to BD. Therefore, point B is midpoint of segment DC. Therefore, according to the definition of midpoint, BC is equal to half of DC. But it is also given that BC is equal to half of AC. Therefore, DC is equal to AC. That is, segment DC is congruent to segment AC. Let us mark it as statement 1. Now, in triangle ABC and triangle ABD, since they are the common sides, segment AB is congruent to segment AB. Angle ABC is congruent to angle ABD, as each angle is of 90 degrees. According to construction, segment BC is congruent to segment BD. Therefore, according to the side angle side test, triangle ABC is congruent to triangle ABD. Therefore, segment AC is congruent to segment AD, since they are corresponding sides of congruent triangles. Let us mark it as statement 2. From the statements 1 and 2, we can say that segment DC is congruent to segment AC is congruent to segment AD. Therefore, triangle ADC is an equilateral triangle. Therefore, from the statement 3, we can say that angle C is equal to 60 degrees. In triangle ABC, it is also given that angle ABC is equal to 90 degrees. Therefore, from the statement 3, we can say that angle C is equal to 60 degrees. Angle BAC is equal to 30 degrees, since sum of measures of angles of a triangle is 180 degrees.